Hey guys, you might have already used some common React hooks such as useState or useEffect in quite a lot of projects, but you have barely used advanced hooks like useReducer, useContext, or useCallback. In this tutorial, which is consisted of two parts, I'm going to give you plenty of examples on how to use advanced React hooks, and you will learn how to improve the performance of your React projects, and you no longer have to really shy away from using these supposedly scary hooks in your projects. In case you haven't still subscribed to my channel, please feel free to do it, and stay tuned. Hooks allow you to use a state and other React features in functional components. In simpler terms, if you're creating an enterprise-level project where you have to deal with lots of dynamic data, then you can definitely feel free to use React hooks. For example, if you're creating an e-commerce website and you have to deal with data that comes from the carts or the data that the user generates or lots of other data that is generated in a dynamic way, definitely you have to deal with lots of hooks. There are several advanced React hooks that you can definitely encounter in your projects, but in this video, I'm going to specifically focus on useReducer, useContext, useMemo, useCallback, and useRef. In this video, which is part 1 of this tutorial, I'm going to specifically give you two practical examples using useReducer and one example for useContext. Reusability plays a pivotal role in big projects. You eventually need to use your components in a variety of different projects, so you don't have to reinvent the wheel or create something from scratch. We also need to comply with the separation of concern principle, so I just try to make every single component as much modular as possible. useReducer is an alternative to the simpler hook useState. It is also particularly useful when you have state transitions that depend on the previous state. For example, if you've got some sort of data, a number, a string or something, and you just want to apply some sort of change, you're going to manipulate it and add something to it or subtract something from it. So in that scenario, useReducer would be a very good tool. It also allows you to manage complex state logic by using a reducer function. During this video, I'm going to specifically focus on every single component to this useReducer, so you will definitely get a very good understanding of what a reducer function is and how the previous state is supposed to be modified using useReducer. When it comes to useReducer, there are 4 important elements that you need to be aware of. The first one is the initial state. This initial state is an initial value and it can get any sort of data structure. It can range from an object to a string or a number. It can represent something like the number of items that you add to your shopping list in an e-commerce project. So any initial value can be a good representative for the initial state. Then we have the reducer function here. Reducer function is actually the main component which is responsible for state transition. For example, try to imagine that you have a shopping list. You have added a few items in your e-commerce project. So you need to subtract from it, or maybe you need to add new items to it. So reducer function is exactly the element that is responsible for applying this kind of logic. I will make sure to delve deeper into new concepts such as reducer functions or dispatch function, so you don't really have to worry about what each element does within a project. Then there is this third element here, the dispatch function. You can imagine that they are some sort of a messenger. They dispatch or send a message or an order to the reducer function, so they will decide what to do with that kind of message or that kind of order. More on that later. And this brings us to the very last one, the dispatch function calls. They're actually the main triggers. They trigger the dispatch function and tell them, hey, it's time for you to dispatch or send this message. Before starting to code, I'm going to give you a mental model in order to understand how useReducer works. So try to imagine that each element represents a real concept in real life. For example, imagine that the initial state represents a house or an apartment where a group of different people with various backgrounds are living. Then we have these calling dispatch functions, the mechanisms through which you can call functions. It can be a group of people, or it can be a person who starts picking up the phone and start calling a particular center. Think of this call center as 911. An operator picks up the phone, and depending on the level of the emergency, he or she decides to dispatch that message to the proper center. For example, that message can be dispatched to a police station or a firefighting department. At the end, the police station or the firefighting department is responsible to apply some sort of change or improve the state of that apartment. To give you a quick recap of what this mental model represents, I would like to draw your attention to this process once again. There's this person who picks up the phone and starts calling a call center. And then the call center decides to dispatch that important message to a group of firefighters. So these firefighters receive the message and then decide to do something about that emergency. So probably they will solve a problem, or they will improve the state of that apartment. Something will change, and those hardworking firefighters or police officers are responsible for that change. Now that you have a better understanding of what useReducer does, let's start coding. I'm going to open the Visual Studio Code here, go to a particular directory. Open the terminal. Okay, so I'm going to start creating a React app. Let's call it Advanced Hooks. Okay, now that the creation process is over, let's see what we've got here. I'm going to type ls to see the folder here. So I'm going to cd into the advanced hook. pwd to check out, to double check the correct directory. Okay, now I'm going to npm start to see the default React app. Since I'm already using port 3000, I'm going to say yes to run it on a new port. So I clicked on Y. Great. Going to open localhost 3001. Okay, let's see what we've got here. So on localhost 3001, there's this default React app. I'm going to get back to the main project. Under the src or source, I'm going to open app.js and get rid of every default value and attributes there. Okay. So as you can see, everything is removed. There is just hello that I just typed down there. The next step is to install Tailwind CSS. By installing Tailwind CSS, you save yourself lots of trouble of using crazy CSS code. So let's do it and attribute the proper class names to each element so that our application will look nicer. Let me just get rid of this one as well. Save it and move forward with the process of installing Tailwind CSS. Let's go to tailwindcss.com. Under this URL, you can easily find the process of installing Tailwind CSS with a React app. Let's start the first step. First step is to create that React app, which we have already done it. Now this brings us to step 2. I'm going to copy the code and paste it here. And press enter for the second line. npx Tailwind CSS init. Okay, great. Now we have Tailwind CSS config file here. Let's get back to the main website. So step 3, we need to copy everything here and paste it on the config file. I'm going to replace everything. Save it. Back to the document. We are on step 4. I'm going to copy everything here and put it under source index CSS. So I'm going to look for index CSS. I'm going to delete everything, paste those codes and save it. Let's start the app. Okay, port 3000 is already occupied. I'm going to press Y. Okay, now we get back to localhost 3001. Now I'm going to apply some Tailwind CSS code to check whether it's been successfully installed there. So I always start with background color. So let's give it a shot. I'm going to go with blue, color code 200, BG blue 200. Save it. And here it is. So the color has been successfully applied. We're going to create this app step by step. So first of all, I'm going to focus on the nav bar here. So we're going to create this nav bar, including all the advanced React hooks here. Let's create the nav bar first. I'm going to add a navigation bar tag here. Inside this nav, we're going to have an unordered list or UL and lots of list items or LI. Every list item should be somehow linked to a URL. So I'm going to add link here. Please notice that link is part of React router DOM. So I'm going to go ahead and install that dependency. So npm install React router DOM. There's also something worth mentioning here. At the time of recording this video, I had a problem with the version of this React router DOM. The latest version was not quite stable, and I had to go through the hassle of working with this link. So I would highly recommend you to go with the version 5.20. So let's add @ here, 5.2.0. npm install React router DOM at that specific version. Press enter. Let's check out the package.json file. And here it is. So this specific version has been installed. Now I'm going to import link from React router DOM. So let me just get rid of this first and import it from here. From React router DOM. Gonna save it and use it in the list item. So the first list item would be home. I'm going to save it. Let's also add a few other list items. I'm going to copy the whole list item here. Let's not forget to put the slash. Next one would be useReducer number 1. I'm going to name the URL same, useReducer. Let's call it A. Paste another link here. So the third one would be another useReducer. So I'm going to call the URL or the endpoint as useReducer B and name it useReducer 2 or the second useReducer. This brings us to the other one. Next one would be a useContext. Let's name it useContext as well. I'm going to save it. Let's start the application. Press Y. Okay, let's open the browser. As you can see, there should be something wrong here. Let's just check it out. So we have imported the link, but look at this. We've got a message. So according to this, we need to use another command to install React Router DOM. So on line 5, you can definitely see that it is npm i --save -dev. So I'm going to go with that one and reinstall it. So let's type this npm i --save -dev space add types /react router DOM. Okay, let's see what things. Okay, so as you notice, the error message is gone. And it is also important to use the router, which comes from the React Router DOM library, in order to create your routes. So I'm going to open the file index.js and change some of the settings. So let's get rid of this report of app vitals. We don't need it. I'm going to delete this as well. We need to import the browser router. Browser router. Let's define it as router. It comes from the React Router DOM. So the next step would be to use the React DOM. And the React DOM will render React strict mode, but this time we're gonna include the router as well. The app is supposed to be inside the router. And at the end, we need to have access to this document. So I'm going to copy it and delete this part. And include it in the render section. Let's separate it with a comma. Save it. Let's go back to the local host. Okay, I'm going to delete this client part and import React DOM directly from React DOM. Let me save it and back to the localhost, and here they are. There's something quite important here to notice. Well, you don't really have to memorize the way that these elements are structured. You can definitely feel free to look at the official documents coming from the React community. So all you have to do in this tutorial is to focus on the logic behind the React advanced hooks. I will also make sure to include the Github repository for this tutorial. Now let's just head back to the app.js and define the very first route. Going to minimize this nav bar and add the switch here. Switch comes from the React Router DOM, so it's automatically included here alongside the link. Inside switch, I'm going to add route. This is going to have a path and also a component. Let's call it the home component. Since this is not defined, I'm going to head back to this part and create a new component. So let's just add a new folder and call it components. So under the source, we have a new folder, it's components. I'm going to add a new component called home.js. And I'm going to add X to differentiate it with the JavaScript code, so it's a React component. Okay. I'm going to create a React functional component. So I just typed RFC, and I'm going to click on tab. And as you can see, this is being automatically added. Just type down something random. Welcome home. I'm going to save it and head back to the app.js. Still, this home is not imported. So delete the last letter, add it again, click on enter, and it's automatically added here. I'm going to save it. Let's switch back to the localhost. And as you can see, welcome home has been added in this route or the main URL. But this doesn't really look nice, right? We need to make it look horizontal. So I'm going to head back to the app.js. Let me open this nav part, go to UL. I'm going to define a new class name. It's going to be flex. Save it. And look at this. Now the nav bar looks horizontal, but in order to make it look better, we definitely need to apply some sort of better classes, right? Since I have already copied some class names, I'm going to move forward with them and add those new classes. So I'm going to drag whole section regarding the nav part and replace it with some Tailwind CSS code. Just saved it. And look at this. This has been beautifully applied there. I'm going to give you a very brief overview of what kind of codes I have used here. So as you can see, the background is blue with color code 200. The nav bar has got an amber with color code 100. It's flex, so everything inside it is horizontal. The space between every single tab is 4. And then here we've got the UL, still a flex part. And I have actually added some hover effect. Once you hover over every single tab, this amber color is applied with the color code 300. So there are some codes for the fonts. So as you can see, it looks a bit bolder. And the codes for the other list items is the same. Now I'm going to delete this high part. The part where it includes the term high is here. I'm going to save it. Okay, we are in the main localhost. So according to this route, the component on the home is supposed to be shown here, and it's got the welcome home. Let's just start creating every single tab one at a time. I'm going to go ahead with the very first tab here, useReducer number 1. So once you click on it, you are directed to this URL, and the whole logic behind the first useReducer will be visualized underneath it. So let's begin. Step number 1 is to define the route here. So I'm going to go ahead and create a new route. I'm going to give it a new path. It's going to be useReducer A. Can be anything. According to our logic, it's going to be the first useReducer. Now I'm going to define a new component and call it useReducer A. And as you can see, it's not defined. So there is basically no component representing useReducer A. So I'm going to head back to source. Under the source, inside the component, I'm going to create a new component called useReducer A. So the format is JSX, a typical React format. Okay, this is going to be a React functional component. So RFC, I'm going to press tab, and we've got this one. So something random first, just to show you that it appears this time differently. So useReducer A, save it. Now let's head back to app.js and make sure that this component is imported. As usual, I'm going to delete the last letter, enter again, press enter, and it is automatically added at the top. Another important lesson that you definitely need to pay attention to is that if you really want every single route here to show something different, to be independent from each other, you should add the term exact here, so that every single endpoint represents one independent component, so they're not mixed up. Let's save it. I'm going to head back to localhost. Okay, right at the moment we are under the main URL. I'm going to click on useReducer, and look at this. This new content has been added under useReducer. So let's now focus on the logic behind the first useReducer and get rid of this random text. I'm going to define a new state, a new data structure that represents number 0. So the initial value would be 0. And then I'm going to define two different buttons. One would increment the value of 0, one at a time, and the other will decrement it and subtract 1 unit from that 0. So this is actually the logic that is going to be implemented under the useReducer A. I'm going to draw your attention once again to that mental model. So in this part, we're going to have two colors, two buttons, two people or two guys that are supposed to actually call. One is responsible to call for an increment message, and the other is in charge of calling for a subtraction or decrementing message. And then I'm going to define two dispatch centers, two operators. One is responsible to receive the first message, the message of incrementing that 0, and the other operator is responsible to decrement it, actually subtract that number. So these two messengers, these two operators are going to dispatch these messages to two hardworking firefighters or two main agents that are responsible to apply this logic to either subtract that unit, that one unit, or to increase to that value of 0. And at the end, that initial state or that 0 is going to change either to be decremented or to be increased. I'm going to define a new state, a new data structure that represents number 0. So the initial value would be 0. And then I'm going to define two different buttons. One would increment the value of 0, one at a time, and the other will decrement it and subtract 1 unit from that 0. So this is actually the logic that is going to be implemented under the useReducer A. I'm going to draw your attention once again to that mental model. So in this part, we're going to have two colors, two buttons, two people or two guys that are supposed to actually call. One is responsible to call for an increment message, and the other is in charge of calling for a subtraction or decrementing message. And then I'm going to define two dispatch centers, two operators. One is responsible to receive the first message, the message of incrementing that 0, and the other operator is responsible to decrement it, actually subtract that number. So these two messengers, these two operators are going to dispatch these messages to two hardworking firefighters or two main agents that are responsible to apply this logic to either subtract that unit, that one unit, or to increase to that value of 0. And at the end, that initial state or that 0 is going to change either to be decremented or to be increased. Let's get back to useReducer components. I'm going to start with the step number 1. The first step is to define the initial state. So I'm going to use a useReducer hook here. The first element inside this is the initial state. Let's call it a state. The second one is a dispatch function. Then these two are actually represented by useReducer. Inside the argument, you are going to actually define a reducer function. And after that, the second value would represent the value of the initial state. So basically, I'm going to define an object. Inside that object, there is a count value, and its initial value is 0. So useReducer is not imported. Let's import it. Automatically import it here. So the errors here indicates that we have not still used them in this application. That's totally fine. We're eventually going to create that logic here. Now let's just bring this state, this initial value, inside the return part. I'm going to delete this part and add a p tag. This p tag is supposed to represent the initial value. So I'm going to call it count. And inside that count, we're going to have access to state. That state is represented by an object. So the first key of that object is called count. Now, I would like to define those two colors. The first color was responsible for sending the message of incrementing, and the second color was in charge of sending the message of decrementing. So basically, these two colors are represented by two buttons. So I'm going to go ahead and define these two buttons. Button 1 and button 2. Well, the first one would be increasing, so I would write down the term increments, and the second one would be in charge of decreasing or subtracting or decrementing. So yeah. Now that we have defined those two colors, they should somehow be connected to the dispatcher, right? So those two agents on the 911 need to hear their message. So I'm going to define onClick here, one onClick for the first button and the other one for the second one. Okay, so basically this function increase is supposed to dispatch that message, and decrease will be responsible to dispatch the decrease message. So this brings us to the next step. We need to define these two dispatchers. Dispatchers are basically functions that can dispatch an object comprised of a type and a payload. Their object can be a type as well. So let me just define one here. I'm gonna go with the first dispatcher, increase. Let's just define it. So it's going to be called increase. It's going to dispatch an object. That object can include both a payload and a type, but in this case, since we're not sending any payload, I'm just going to define a type for it, and I'm going to call it increment. So basically, this is the message that that dispatcher is going to send to those two firefighters or to the reducer function. I'm going to save it and do the same for decrease. So I'm going to define the second dispatcher or the second dispatching function. So it's going to be decrease. Once again, this is not going to have any payload because we're not sending any payload to the dispatcher, to the reducer function. It just includes a type. So basically, it's going to dispatch an object consisted of only one key called type, and we're going to call it decrement. So decrement would be the message that this is going to dispatch to the firefighters or the reducer function. I'm giving you these analogies to help you solidify these complex topics. As a matter of fact, Richard Feynman, the great American physicist who won the Nobel Prize in Physics, has a quote along these lines saying that you learn a complex topic well only if you can teach it to a child. As simple as some of these mental models may look, they have tremendously helped me better understand these complex topics. So hopefully they can give you a boost in your learning process. As you can see, the only remaining part of this whole logic is the reducer. So I'm going to go ahead and define the reducer function. Basically, the reducer function receives two arguments. The first one is the state, the initial state that is already defined, and the second one is action. So I'm going to define a switch statement here. So switch is an advanced if, right? So if the action type equals certain cases, for example, the first case, let's call it increment. In other words, when this reducer listens to the increment message, something should happen. The increment mechanisms should be triggered. So I'm going to add increment here. So in case of an increment message, the state should change to the following. There is a count. The initial value was 0. So first of all, it should have access to it. State.count. Now we have access to the initial value here. And whatever it is, should be incremented by 1 unit. There is also another message that this reducer function expects to hear, the decrement message. So I'm going to define another case here, case decrement. I'm going to copy it here, put it there. So in case the action type is decrement, we need to change the state based on this logic. So we need to first access to count and decrement 1 unit from it. And the reason you see this warning message is that switch needs a default part as well. So in order for us to finalize this whole logic, I need to add default, which means if none of the above logic happens, if none of those two messages are received, just return the default value of state. So return state or the initial value, which was an object with count 0. I'm going to save this. Let's switch back to the localhost. So under the useReducer, I'm going to click on it. As you can see, we have access to the count. This part, the initial value was 0. And we have access to 2 buttons. They do not look very beautiful, so we need to add some class names from Tailwind CSS, but more on that later. I'm going to click on the first one, increment. And as you can see, 1 unit is added to the initial value of count. As I keep clicking on this button, value will be added. On the other hand, if I click on decrement, 1 unit is subtracted from the initial value. Now, just go ahead and add some beautiful classes to make it even look nicer. I'm going to replace this div with another one, which includes some Tailwind CSS classes. Let me just save it. Let's see what we've got here. So first of all, we have access to a p tag with the margin 4. So the initial value is supposed to be 0. And then we've got the first caller, the first button. As we click on increment, this center, this dispatcher will dispatch the message of increment, and the reducer starts to listen to that and take the proper action. And then we've got another button, another caller. Once we click on the decrement, this decrease dispatcher, this function, dispatches the message of decrementing, and our reducer starts to listen to that. And in case of an in case of decreasing or decrementing, 1 unit is subtracted from the initial value. So I'm going to save it. Just head back to the localhost and look at this. We have access to the same buttons, but this time they've got a better look, right? So as I start to click on increment, 1 unit is added to count, and as I keep clicking on decrement, 1 unit is subtracted from the initial value. Further clarification, I would like to draw your attention once again to the reducer function. You remember those 2 hardworking firefighters, right? So first of all, there is a conditional statement here. This if or this switch command actually accepts some messages from the dispatchers. In case of an incrementation, there should be 1 unit added to the initial value. So I'm going to write a console log here and call it increment. And I would like to add another console here under the decrement. So once these two messages are dispatched, you gotta expect to see something, right? You gotta expect to see that these console logs are triggered as well. So this whole logic takes place as well. I'm going to save it. Let's just head back to the localhost. I can click on F12 or simply go to the console. So I am going to dispatch an increment message. This is a caller. So the caller dispatches a message called increment. And as you can see, this console was responsible for showing the increment message. And then this return section actually does the math and increment it by 1 unit. And if I click on decrement, the second caller, the second button actually, is triggered, triggers a dispatch message. The message of decrementing is sent to this reducer. This switch action is activated, and in case of a decrementing, this logic will be activated. So I'm going to click on decrement and look at this. This decrement message was fired. Now that you have a better understanding of how useReducer works, I would like to draw your attention to the second one. The second useReducer is supposed to be a note-taking app. Let's go ahead and start creating that one, which is a bit more complex. Let's add the route first. This is going to be the second useReducer, so I'm going to add the second route. Let's call it useReducer B. So the endpoint is useReducer B. We're going to create a component and call it useReducer B. As you can see, it's not defined yet. So I'm going to go under the component sections and create another component called useReducer B. So let's click on this part. Let's call it useReducer B JSX. It's going to be a React functional component. Press tab. Let's just add a random text. This is gonna be useReducer B. Save it and head back to the main application on localhost. Okay, probably we haven't saved anything yet. Yep, so we need to import it. Okay, it's been automatically added. Here it is. Let's switch back to the localhost and look at this. This random message appears under the useReducer. Now it's time to create the whole logic. So I'm going to get rid of this one and start implement it step by step. Basically, the second useReducer should look like this. It is comprised of two horizontal div, and the one on the left is actually where we can type the message and click on add item, and it gotta appear on the right div, something like this, like wake up at 6. So you got a logic, and at the end you gotta be able to delete these messages accordingly. Okay, so first of all, let's define a bigger div, which encompasses those two horizontal divs. Okay, this will have one right div and one left div. So the main one should have a class name flex in order to turn these two divs into horizontal sections. So let's call it left div and call the other right div. Save it. I'm going to go ahead and add a vertical margin with code number 4. So MY4 represents a vertical margin here. Okay, let's switch back to the localhost. And here they are. They don't look very good, so let's just add some class names here. I'm going to define a class name for the left div and a class name for the right div. I'm going to save it. So as you can see, this W indicates the width of these child divs. So it basically says that this is going to occupy half of the screen or half of this parent div. We've got a border, and for the border, we've got red color with color code 500. I'm going to save it. Let's head back to the localhost and look at this. So the width has been broken down into two separate parts. They are cut in half, and we have defined a border with color red and color code 500 selected here. I'm going to delete the left div message here and instead add an input along with a button. I'm going to save it. So basically, this is a text input where the user can type down something, and this is the button that says, hey, you can add an item to the right part. Save it and head back to the localhost and look at this. So this is the input, the text input where you can type down something, and this is the button where you can add it to the right section. So let's focus a little bit on some CSS code here. So there's an ID input. The type is text. We have defined a margin with code 4. So the margin is 4. The border has been defined with the gray color code 300. So it's going to be rounded. As you can see, there are some beautiful rounded corners here. So the padding y, or the padding across the y-axis, is 2. Padding x, or the padding across the x-axis, the horizontal axis, is 3. The text color is supposed to be gray with color code 700. We have a placeholder. This placeholder, enter your items. The color code is 400 for the spectrum of gray. So basically, this enter your here message is defined with gray color. So once you focus, the outline is gone. Once you focus, there's going to be a ring added. Ring is supposed to be blue with the color code 500, and a transparent border is defined for the focus. I should somehow have access to the value that the user types here. So I'm going to define a value section under the input part. And let's attribute an initial value for this I'm going to go ahead and define a set state. Let's call it input val. And let's define the setter. Setter function is called set input val. This is going to be an object. Let's call it content and leave an empty string here. So basically, the initial value of this input is supposed to be an empty string. So I'm going to write down the initial value, which is input val dot content. So basically, I am creating a connection with this object. I am having access to it by addressing it with this key input content. Let's switch back to the local host. So as you can see, whatever that you want to type down here appear inside the input, but should somehow have access to it. So I'm going to define a new event listener. It's going to be an onChange. And once something changes here, in other words, once you are typing a character here, it should be triggered. So I'm going to call it handle change. And I'm going to define handle change here. Const handle change. This is going to receive an event, and I'm going to console log this event target value. So basically, we are having access to whatever the user is typing down there. Let's head back to the local host. I'm going to open the console section. Okay. As I type down letters, they perfectly appear on the console section, but nothing appears on the main input. And the reason is the initial value for that main input is set to an empty string, right? And even though I am typing down different characters here, they're not set for this initial value. So we're going to update the value of input val using the setter function. I'm going to go ahead and use this setter function here. The initial value is an object, and in order to update an object, you can go ahead with the spread operator. So I'm going to use a spread operator. The initial value is input val. We're gonna manipulate the first key or the only key, which is content, and it's going to be upgraded with whatever the user is typing down there. So eTarget.value would be the value added by the user. I'm going to save it, and I would expect as the user changes something on that input, this handle change is triggered. You would be able to see the console message, and eventually this initial value will be upgraded as well. So I'm going to reload this section. Hello. And as you can see, I am able to type down different characters here inside the input, and everything appears under the console section too. Before I move forward with implementing the events for this add item button, I would like to draw your attention once again to how this works. Basically, you're going to type down something inside this input, click on this button, and that text will appear on the right section. We need to create a place, a data structure in which this value can be stored. So I'm going to define a state, that initial state where you can store all the value coming from this input section. So basically, we will end up having an array containing all the information coming from the left section from here. So you will have an array which is consisted of wake up at 6, brush your teeth, and grind coffee beans. The next step is to create the logic behind the button. Once you click on that button, that value should be added to the right section. So I would like to once again draw your attention to this mental model just to have a quick recap. We're going to create a color. That button is the color. Then there's going to be a message dispatched to the dispatcher. The dispatcher would be a function responsible to let the reducer know that we're going to add something to the to-do list. And the reducer function will eventually upgrade the initial state. So I'm going to add a new event listener. So this new event listener is going to be an onClick. So once you click on this button, something should happen, right? So let's define it. This is the very first step. This is the color. This color is responsible to call a particular dispatching function. Let's call it add task. And the argument for this add task is exactly what the user is typing down here. For example, if the user is typing wake up at 6, this value should be transferred to this add task, which is supposed to be a dispatcher. So I would like to bring this value, which is represented by the input val, and send it back to a dispatcher function, which is going to be named add task. So I'm going to write down input val. As you can see, this warning here indicates that add task is not defined. So I'm going to go ahead and define this dispatcher. It's going to be a function called add task. This function is supposed to accept a payload, something from the input val in this scenario. So I'm going to call it new task. It doesn't matter what you call it. As long as your logic is correct, you can name it whatever you want. And you remember, these dispatcher functions had this dispatch, which came from the useReducer. And they dispatched an object which had a type and possibly a payload. In this scenario, since we are adding something, we're adding a value from the left part to the right part, we definitely need to add a payload here. So let's start with the type first, and I'm going to define exactly what kind of payload we're going to add. First of all, the type doesn't matter as long as you name it something self-explanatory. It's working totally fine. So I'm going to call it add item. So basically, this is the message that is going to be dispatched from this dispatching function to the reducer function. And then we've got the payload. The payload is supposed to be the exact value that is typed by the user here, and then it's going to be saved somewhere in the initial state. And this initial state is going to be represented by an empty array. Now I'm going to use the useReducer. So it's going to have the initial state along with the dispatch function. It's got a reducer function. It's call it useReducer. And here comes the most important part, the initial value. The initial value is supposed to be an empty array. So basically, the user starts the process by clicking on the Add Item button, and then a message is dispatched from this dispatcher. This message contains the type Add Item, and this task reducer is supposed to listen to it and take the proper action accordingly, which is going to be adding one item to this empty array. I have barely touched on this delete button so far, and we haven't addressed it yet. Basically, we're going to create a mechanisms through which you would delete this item based on a particular ID. For example, if I click on this delete button, the first item was deleted. So basically, the selection of these items is based on that uniqueness, and I'm going to tell you exactly how I'm going to create a unique ID through which you can easily delete whatever you want from this list. My ideal payload would look like this. For instance, I will have access to an object. The first key would be the content, something that the user is typing. For example, wake up at 6. And there's going to be a unique ID, something like 1, 2, 3, 4, whatever. And I'm going to reach this uniqueness by using the date now function, which allows me to have access to the timestamp, and it definitely creates that kind of uniqueness that we can easily separate every single content from the list, and later on we can easily delete those items based on these unique IDs. Let's have a sneak peek at the date now. Date now, and look at this. There's this unique value that comes from this timestamp, and every time it changes. And this brings us to the final step. We're going to define the task reducer or the reducer function. So I'm going to go ahead and define it. Copy this. Remember that the reducer function is comprised of two arguments. The first one is the state, and the second one is the action that is dispatched from the dispatchers. This is going to have a switch, and this switch receives the action types. In case someone is adding an item, in case we've got this add item which comes from the first dispatcher, it is supposed to do something particular. In other words, it's going to add that new item to this empty array. So I'm going to use return and use the spread operator, and at the value that comes from this payload. So action.payload. Please notice that your switch function will be incomplete as long as you don't have the default value. So if nothing happens, it gotta return the initial state. So in case of a default situation, please return the state. I'm going to save it. It's time to run some tests and see what happens if someone clicks on add item. So I'm going to define a new state. Let's call it new state. And I'm going to do the exact same operation here. I'm going to add that payload to the state, which is supposed to be an empty array, right? So I'm going to copy this. Let's copy this whole thing, put it here, and I'm going to console log this new state. New state. What I'm going to do right now is to do this whole logic. I'm going to start with this color. I'm going to click on that button. I'm going to add an item. And once I'm adding this item, this dispatcher add task is triggered. It creates a payload. This payload is supposed to be comprised of two keys. The first one is a content, and the second one is an ID. And then this payload will be sent to the task reducer or the reducer function. This reducer function understand that the case is add item, so it starts to do this whole logic. It's adding that payload to the previous state, and it's supposed to show us this new state. I'm going to save it and head back to the localhost. Let me open the console. And I'm going to add something here. Let's say wake up at 7. I'm going to click on add item. And look at this. Here is the new state. And as you can see, the new state is comprised of two parts. The content, which is the text or that string, wake up at 7. And the other key was the ID, which is a timestamp. I'm going to add another one. Let's add, for example, another text here. Click on the button. And look at this. The new state is updated. It's got two values here. Every single value is represented by an object, and every object has got two keys, content and the ID. I would like to draw your attention to the value of these IDs. They're different, they're unique, and they can definitely satisfy the conditions of our problem. Realistically speaking, we don't really need all of these messages, so we need to first get rid of all of these console logs and then try to create a mechanisms by which you will transfer every single item to the right div. So first of all, I'm going to get rid of this first console log message. You don't even need this new state. And then there was another console log which came from the handle change. Once you were typing down something on that input, you had access to that value in the console section. So I'm going to get rid of this as well. And all I'm left out with is this state, which has not been used. I just use it to show you how those items were added to that empty state. Now, I'm going to bring this state to the right div, create a map, and then bring all the data on that right div. So let's scroll down to the right div. This is the right div. Let's delete the default text. I'm going to use the state here. I'm going to do a map here. This map have access to every single value inside that state array, and it's got an index. So inside this map, I'm going to create a div. This div is supposed to have an h1 text. This h1 tag will show you something. At the moment, I'm just going to hard code it, but later on this will be dynamic and it will accept the value coming from the state. But at the moment, just for the sake of this tutorial, I'm going to add something fixed. And then we're going to have access to a button. And that button is called the delete button. So please do not forget to add the key to every single map. So it's going to be unique, and that uniqueness comes from the index, which represent the index of every single value inside an array. Okay, I'm going to write index here. Let's save it. Let's switch back to the local host. I'm going to add something here. Click on add item. And look at this. It appears here. We've got a delete button and a fixed text. Let me add another text here. Click on it, and as you can see, another text was added here. The next step is to make them look horizontal. So I'm going to add a flex class name to this div. See? And they're horizontal. And here it is. The next step is to make them look nicer. So I'm going to replace these codes with some beautiful Tailwind CSS class names. It's also worth mentioning that we're not going to use some hard-coded values like item1. We're going to have access to the value of the estate, so I'm going to exactly use them. We're going to have access to the content of each value. So once again, hello, and click here. As you can see, this is not item1, this is dynamic, and it is dynamically transferring from the left div all the way to the right div. Okay, let's go to the next step and add those class names. Let's replace this state map with something that looks nicer. Okay, so we've got the main div and h tag here. Let me just put this key inside the main div. So we have access to an h tag here, the value comes there, the value that the user types is going to be represented here. We've got access to a delete button. It's got some special class names like some border, background color. Save it. Let's switch back to the local host. Add some item. And look at this. We have access to a text, and the delete button is at the far right of this new div. Add the second item, and here it is. As you notice, while I am adding something here, the previous text still appears on the input. For example, if I write down and click on item, add item, still this text appears here. So this is normally a bug. We need to get rid of this and create a system in which while you click on add item, the text disappears as well. So let's head back to the main code and look for a place or a function that is responsible to activate this add item. So it's the first button, right? While you were clicking on that button, this add item, this add task was triggered. Now I'm going to add another function or another mechanisms by which you can easily get rid of this value. So let's just add another function here. What I'm going to use to reach this goal is to use the setter function of this input value. You remember that the initial value, whatever you were typing, were stored in the input val. Now I'm going to go ahead with the setter function, set input val here, and upgrade the value of the state here, or the input val. Okay, I'm going to paste it here. Now I'm going to change the initial value of this input val. So you remember, input val was an object. And if you're supposed to update an object, you got to use the spread operator. So I'm going to use it. This is the original value. All I'm going to do is to turn the content into an empty string. I'm going to save it. So basically, I expect that once the user clicks on that button, this add task is triggered. And then this setter is supposed to be activated and get rid of everything inside that input. Let's just head back to the localhost. I'm going to add a new item. Let's click on it and activate add item. So as you saw, it disappeared. So add task was activated, and then subsequently this setter function came into play. Let's wrap up useReducer by creating this delete mechanism. I would like to once again draw your attention to that mental model. First of all, we need to define a caller, and this is supposed to be a button. Once it's triggered, a message is sent to the dispatch function. The dispatch function is supposed to let the reducer function know that a certain value is supposed to be deleted. And then this reducer function will go ahead and delete that value from the initial state. So let's focus on this delete button first. We're going to define that trigger or onClick event handler. So we're going to have an onClick event handler here. Let's call it delete task. It's supposed to get the value based on the ID. And here's the value that we get from the state. All those objects that were comprised of an ID and a content. Remember that? We're going to give this ID and then trigger a dispatch function. So step number 1 is completed. Now we need to head back to step number 2, which is defining the dispatcher function. I'm going to copy this delete task and define this new dispatcher. It's supposed to get an ID and then dispatch a message to the useReducer. This object is comprised of a type. Let's call it delete item. And here comes the payload. So the payload is the ID which is passed from this caller. We're going to pass this value.id to the dispatcher function here. And then this message, the message of deleting item, will be sent to the reducer to finalize this whole process and get rid of that specific value from the initial state. Let's save it. This brings us to the final stage. We're going to define a new case for the switch. And that new case is the delete item. I'm going to copy this message, delete item, and put it here. So in case of delete item, the switch is supposed to do this. It's going to filter based on that ID. So I'm going to add state.filter. You know what this filter does, right? It checks every single value inside an array and decides to filter based on a certain condition. This certain condition is supposed to be like this. Check out the ID of every single object. If it is not equal to the payload that comes from that action, then show whatever is remaining. In other words, if the ID doesn't match, don't show it. Filter it. Just show the ones that have a different ID. So I'm going to save it. Let's switch back to the local host. I'm going to add a bunch of value here. Okay, so as you can see, we have access to these two items. As I click on delete button, it disappears. And that's it. This is how we just created the second useReducer. There is still one thing that I think it's worth mentioning here. If you click on this add item, you can see that these empty values will be added here. There's nothing here, so basically it's a bug and we need to fix it. We need to focus on the root cause of this problem. So the bugs are coming from this add item. We need to fix something about it. So I'm going to focus on the first button here, add item, and define a particular condition. I'm going to say, hey, add item, please do not add anything if the input val is empty. You remember this input val was an object consisted of content initially, right? So I'm going to create this conditional and say, hey, if this content is empty, you're not supposed to be triggered. You're not supposed to be sending that message to the dispatcher. So I'm going to add input val, and I need to have access to the content. And by adding these two ampersand, I can say, well, as long as it's true, as long as it exists and there is something inside that content, then you can feel free to fire this add task. I'm going to save it. Let's head back to the local host. It's empty. Just refresh this one. It's empty. I'm going to click on add item. And as you see, nothing is added. But if I write a world and then click on add item, it appears here. If you hang on up to this part of the video, give yourself a pat on the back because you truly deserve it. And you definitely have my admiration and support. And please do not forget to subscribe to my channel. It helps the channel a ton. Sit tight for the next scary hook, which is supposed to be useContext. UseContext is a hook that allows access to the value of a context directly within a functional component. It also provides a way to pass data through the component tree without the need to pass props manually at every level. In other words, I would like to draw your attention to the concept of prop drilling, where you pass props from parent components all the way down to the children components. By using useContext, you don't really have to go through the hassle of drilling props and transferring one level after another. In fact, you define a single source of truth, a place where everybody will have access to the same data. UseContext also comes with a variety of different advantages. For example, its simplicity is a big plus. It simplifies the process of consuming values from context within functional components. So you don't really need to pass props traditionally down the component tree. Other than that, its readability is another great advantage. Your code becomes more readable as the context value is accessed directly within the component. It avoids the need for prop drilling, which can potentially clutter the code base. Another great benefit of using useContext that can tremendously improve the performance of your application is its flexible update. Actually, when the value of the context changes, components using useContext will automatically re-render only if the relevant part of the context has changed. Don't panic, you don't really have to feel overwhelmed with lots of documentation related information. If the documentation were straightforward enough, who would use the YouTube tutorials anyway, right? That's why I'm going to give you a mental model along with an example to help you solidify this concept. Let's take a closer look at this example. We've got a use context here, and inside this use context, there are two sibling components. Component 1, child A, and component 2, child B. As you can see, there is a price attributed to child B. Let's assume it's $100. On the other hand, child A has got a button. You can easily click on this button and see that the price changes accordingly. Traditionally, you had to transfer some functions or props from the parent component all the way down to the children component, and one child could trigger those functions or change those props, and eventually that change would have to be transferred to the sibling components. So lots of complications were there. But here in this example, we're defining a single source of truth where these changes, functions, and variables are defined. And that's called a context. Needless to say, once I click on this button, something changes in the use context, right? And that change is linked somehow to another component, to another child component. So the second child component will accept that change which comes from the other child component or child A. Let me draw your attention to this mental model which perfectly represents a real-life scenario. Imagine that you and your sibling decide to open a joint bank account and get a membership from the bank. All you need to do is to choose your bank, go there, and open a bank account. This bank account can be a saving account, or a credit card, or a checking account, or a line of credit, or whatever. Once you decide the type of bank account that you're applying for, you can sign the papers together with your sibling and officially enter a contract with the bank. At the end, you and your sibling have the luxury of using your membership cards and splurge the heck out of each other's money. In conclusion, you first create a context, the moment you and your sibling decide to open a bank account together, right? The second step was to create a provider, or to choose your bank. The third step is to define your context value, which can be variables or functions, and pass it to the provider. In other words, you decide the type of your bank account. Step 4 is to wrap the provider around the sibling components. In other words, you are entering an official contract with the bank, and bank will cover you. The final step is to use the element of context value in your sibling components. In other words, you need to somehow use your credit cards or your membership card in order to have access to its benefits. Let's start with the first step. We need to create a context here. I'm going to create a new folder here. Let's call it contexts. Inside this context, I'm gonna define a file called context A. Okay, from that mental model, you remember that the first step was the decision to open a joint bank account or to create the context. So I'm gonna write it like this. It's going to be called my context. You can name it whatever you want. And then we need to create that context. The second step was to go to the bank or create your provider. I'm going to write it like this. Let's call it my context provider. The name doesn't matter. It's going to get children. The third step was to define the context value, or figuratively speaking, you decide the type of bank account that you need to open. Going to write context value. It can be variables or functions. So for the sake of this tutorial, I'm going to use both of them. So variable 1 is named, let's say, A, and it is a text or string. So, hello, guys. Second variable is supposed to be a function. Let's call it some function. Get something, and then it adds it to itself. Now, we need to bring them inside the context value, A and sum. Once again, the third step was to define the context value, the kind of information that is going to be shared inside the children component, or whatever component that is supposed to use this context. So this myContextProvider is a function and it needs to return something. I'm going to finish it by writing return myContext.provider, and inside it comes the children. And then here we pass the context value as value. Something that I'm going to specifically emphasize here is the syntax or whatever that I have written down here. Please make sure to stick to this syntax. Like, this context provider should be the end of your return part where the value is added as a prop. You should also notice how this myContext is defined separately from the provider, and they are individually exported. And believe me, compared to what you have learned so far, memorizing these syntaxes should be a piece of cake for you. So, a big shout out to you. So far, we have completed the first 3 steps, and now it's time to focus on wrapping the provider around the sibling components. So in the next step, I'm going to define some sibling components and then bring them inside the provider. So in the next step, I'm going to define 2 sibling components here, which are supposed to be horizontal, and they should somehow have access to the context information or the context value and change them accordingly. Let's create 2 sibling components. So under the components, I'm going to define sibling A. I have already copied some codes. Let me just paste them here. So it's called sibling A. It's returning a div here. It's supposed to be flex. It's got access to an h1 tag, child A. There's supposed to be a button that we can simply click on it, and then I'm going to use an onClick event handler, and it should do something about it, and I will define those functions later on. So this is sibling A. Let's define sibling B as well. I'm going to define sibling B under components. So sibling B. I have already copied some code, so I'm going to paste them here. It's called sibling B. It only has an h1 tag. It's called child B. We're going to have access to a price, which will eventually come from the context. I'm going to save it. Let's not forget that sibling relationship is defined within a parent, right? They are sibling as long as they have a parent. So I'm going to go ahead and create their parent as well, still inside the components. Let's call it parent. So this is just a typical React functional component. Inside this div, we're going to bring those sibling, and this is what we're going to do. They're called sibling A and sibling B. They need to be horizontally located, so I'm going to add this class name flex. And let's define a margin for code here as well. So far, we haven't created this useContext. The URL exists, but nothing appears here. So let's just get back to the app.js and finalize this part. At the moment, we're focusing on useContext. It's going to be linked to this URL, so I'm going to copy this useContext A. Let's define a new route. The path would be useContext A, and the component, guessed it right, the parent component. Okay, let's make sure that it's being automatically imported here. Let's wrap it up. I'm going to save it. Let's switch back to home, localhost. So under the use context, let me just click it and look at this. These two horizontal child have been added here. You have access to a button here, and those fixed values, those hard-coded values appear here on child B as well. Now, let's delve deeper on the remaining steps. We need to help these two children have access to their membership's benefits, right? They need to have access to the information coming from the context, and they need to be able to affect each other. For example, child A should be able to change the value on child B. In order to provide the context value to the children components, we need to wrap them inside the provider. So step 4 will be completed as long as the sibling components are perfectly wrapped inside the provider. So I'm going to go ahead and focus on the parent components, the place where this provider should be given and everything should be wrapped inside it. So I'm going to define a provider. The provider is already created, and if you remember, it was called my provider, my context provider. And I'm going to bring everything else inside it. Save it. As you can see, my context provider is wrapping everything inside it. And this brings us to the final step, step 5. Now we need to use the element of context value in our sibling components. In other words, figuratively, we need to provide the membership card to each sibling component so they can use it and spend their money. I'm going to head back to one of the siblings here. So we need to have access to the my context. Let's define it as data. Let's use useContext. And the context that we had already created was called myContext. Let's put it outside the return section. Okay, as you can see, myContext has been automatically added here. All we have to do is to console data and see what it actually is. Data from context. Okay, let's head back to the localhost. Going to open the console section. Let's refresh the page and look at this. Data from context is comprised of two keys, A, which is a string, sum, which is a function. And you remember that these two values, these two keys, were defined inside the context. That was actually step number 3, if you remember it. We defined both values and functions, and then we provided it through the provider. Now I'm going to go ahead and give a default price for sibling B. So this is going to come from the context. Let's define a use state here. Let's call it price. Let's set the setter function, set price. So the initial value would be $100. So user state is not imported. Let me just import it automatically. Okay, looks good. Now we have two elements here. The first one is a numerical value. It's a price. And the second one is a function. I'm going to go ahead and bring them here. So here's the first value, price, and here's the function, set price. You know, it's really interesting that VS Code automatically differentiate these colors based on their elements, based on the nature of those elements. For example, the values or variables are represented by color, while the functions are represented by blue. I think this is a really great job. And well, we don't really need to use this sum function, so I'm going to get rid of it. It was there just to show you how you can use function inside the context. I'm going to save it. Let's just head back to sibling B. We need to have access to the price. So I'm going to comment out this, and instead I'm going to deconstruct it by doing this. I'm going to have access to price. This price comes from the useContext, and that useContext was called myContext. Now that I have access to this price, I'm going to put it here. Let's save it. I'm going to get rid of this console log. Now let's just head back to sibling A. You remember that I just defined a handler. Inside this handler, we need to have access to a controller, that setter function, and we need to change the value on the sibling component or on child B. So I'm going to go ahead and bring this set price. Okay. So set price is supposed to come from the useContext. Let me just deconstruct it. It was called set price, and it was coming from myContext. It's automatically added here. Great. Now I'm going to use set price. Okay, whatever value that I can give here will be set to the initial value of price. So, well, let me just add a random number here, 999. I'm going to save it. Let's head back to the localhost. Okay, great. As you can see, this fixed value has been added here, and this comes from the context, $100. Now, I'm going to click on this, and I would expect that this value would change because it is somehow connected to the setter function. And look at this. The initial value 100, which came from here, changed because set price was triggered. Set price was inside child A, while that fixed value was inside child B. So let me just do another cool thing here. Let's say you're going to somehow have access to its initial value, the initial value of price. So you can definitely go ahead and define a function inside the useState setter function. So this price would represent the initial value, and let's say I'm going to multiply it by 99. So 99 multiplied by the initial price. Let me save it. Let's head back to the localhost. Let me refresh it. The initial value was 100. Now I'm going to click on this and look at this. 99 was multiplied by 100. If I click on it again, well, another big number. In a nutshell, we just created a context, or figuratively, we made the decision to open a joint bank account so the sibling can enjoy it. And then we created a provider, or figuratively, we chose a bank. And then we went ahead and opened a bank account, or we defined two components, two elements. One was a variable, 100, and the other one was a function, or the setter function of that user state. And then we passed it to the provider. In step number 4, we figuratively convinced the sibling components to sign a contract with the bank, or to have access to the variables and the functions that were provided by the provider. In step 5, we imported the membership card from the context and provided it to every single sibling component. In other words, the sibling components were able to have access to the context value, which came from the context. And this is how you can use useContext and save yourself the trouble of prop drilling. And wow, that was quite a journey, wasn't it? Give yourself a pat on the back. This was the end of part 1, and in part 2, I'm going to specifically focus on useMemo, useCallback, and useRef. If you like this video, please feel free to hit the like button and subscribe to my channel. And stay tuned. Over the next week, I'm going to upload the second part.